Okay, page 4. So, mechanisms. Um, we'll tackle these one at a time here. Uh, all right, so pause here, right, if you want to take a look and copy down what we have. Here's, again, I asked you guys to start looking at the functional groups, right? So we've got a carboxylic acid, and here we have this guy right here. Now, the one in yellow is going to be the important one, right? So that's an acetal, right? That's an acetal group. And so what you have to start to see, right, whenever you see an acetal, right, it's a protecting group. It's hiding something, right? It's hiding a carbonyl, right? That yellow carbon right there is going to be our carbonyl carbon. So we know it's got to be that guy right there. So we know that these two carbons right here, right, the yellow and the purple, have to end up as that aldehyde over there, right? The oxygens, let's just use green for now, right? The oxygens of an acetal are both bound to what started out as a carbonyl carbon, right? They started out as a carbonyl carbon. So that yellow carbon right there is that carbonyl. So we know that this acetal group, right, turns into that aldehyde over there, right? Okay, so we got that. So that's kind of the key to getting this started, right? Now you're right, right? You might be saying, well, wait a minute, can't an can't a carboxylic acid react with an acid? Yeah, of course it can, right? Yes, we can protonate that carbonyl oxygen, and we could bring in water and all this kind, right? But that's just going to turn a carboxylic acid into another carboxylic acid, right? That's not really going to get us anywhere to begin with, right? So let's start out by getting rid of our acetal group there, okay? So essentially, right, acetals are ethers, right? There's just a diether, right? That's, we got carbon groups on both sides. There's nothing magical about that, right? So we're going to start out by knowing that ethers react with acids, right? So I'm going to skip all the colors here for a while until it becomes super important, just because otherwise we'd be here for hours trying to, change all the different colors. Okay, so we got that. So what does this mean, right? What does this mean? We, right, so now we made a better leaving group, right? We made a better leaving group. So what can we do? Well, there's a couple different ways you could approach this, right? We could kick off, right? We could break off a couple of different things here, right? We could break that bond and leave a carbocation, or, we could leave that, we could break that bond, or, any of these different ways of doing it. And truth be told, there's probably several ways that this happens, right? But what we're going to do is this, right? We'll do that right there, right? Let's see what happens if we follow this set of reactions here. Boom, 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 right? Mm-hmm. H. Okay. And then so far so good. All right. Again, we're at a crossing point where we could pick different ways that this, that this next step could happen. Let's just follow, let's say, a different path here, right? So to go in the theme with what we have, right? To go along with the theme of what we've been seeing, right? So this is basically a carbonyl group there, right? So we have an activated carbonyl, which is susceptible to attack. So let's bring in some water here. let's do the proton shuffle. And we're going to go ahead and set up the next part here, okay? So we shuffle one of those protons off on the incoming yellow water while we protonate this guy over here. Oops, I'm sorry, I put that methyl group in the wrong place there. Okay. All right. So far, so good. Now, truth be told, right, is this the only way that we can get rid of an acetal? The answer is probably. I mean, well, no, the answer is no, right? There's another way we could go through this. But we kind of avoid any carbocations that might get formed along the way, although those would likely get quickly, mopped up with water anyway. So there's multiple ways of approaching this that I accepted as an answer, right? Let's deal real quick with this, what happened over here, right? Let's deal real quick with what happened over there. So I'm going to box this in green here, right? So we had this, right, bound to yellow H that made that, right? And so we'll do the proton shuffle one more time. Oops, sorry. I got ahead of myself there, right? Just emphatically put that hydrogen in there, right? The hydrogen was here all along, right? It's just understood, right? So there we go, right? That's how we make our aldehyde right there. This is a good pausing point. This is a good pausing point. We've taken care of one of it, and we've gotten to a good, right? We've gotten to a good pausing point to continue the next part, right? Because we want to make this other group here, right? We're going to use this to turn it into that right there, okay? So I'm going to stop the video here. We'll pick this up in part 2 of part 1 of page 4. See you guys in just a bit.